Faith?
Okay, let's pray. Heavenly Father, we thank you for today. We thank you for the gift of life. We thank you, Lord, that you've enabled us to wake up early for this lesson. Guide us as we start. Guide our teacher. Teach him what you want us to learn today. Help us also to understand and that this lesson may be of benefit to us and that we may learn from it. We thank you. We bless your name for today. In Jesus' name we pray. Amen.
Thank you so much, Faith, for the word of prayer. Good morning, everyone. Today, our major area of concentration is going to be on what we call scalar or what we call dot product. So that should be your heading, what you call scalar product or what you call the dot product. And I know you have heard about the word dot product before, or you may have heard about product, more so when you are looking at the multiplication. So that is what we are going to look at in today's session. When you look here, I don't know, in case you know this area or you have seen this area somewhere in Uganda, kindly feel free to raise up your hand and you share with us where you have seen this area. Anyone who has seen this area somewhere in Uganda? Okay. Yes, Gilbert? Let me ask Gilbert where you have seen this place.
Yeah, I came to see that place uh last year in December.
Ah,
Like it's on that road when you are just past Busitema University as you are heading to Tororo, or when you are going to Malaba. That road there is some two stations of where there are those solar panels.
okay. Thank you, Gilbert. Yes. Very good. Some people have seen this, the solar plants in Kalangala, Kalamoja, Tororo. Yes, you are right. You are right. People have taken those roads. You have seen them. Even those people are coming from those ends of, which area is this? These ends in Busoga. Mayuge, yes. Even in Mayuge, you may have found a solar plant. Now, putting those solars the way you see them, it's not that you just go and put them the way you want. No, there is some mathematics behind. And that mathematics is what we are going to look at today. That in order for you to be able to tap maximum sunlight, such that those solar powers can generate those like the energy you want, you must orient them at the right angles. You must be able to tap the maximum light. So the mathematics behind is what is that knowledge of dot product. So these solar panels can only produce maximum power when they face the sunlight. Now, what you need to do is, one, there is application of vectors that you must ensure that the sun rays are in one direction, and also you must ensure that the panel faces the right direction. So once you do that, it means that you are working with the maximum power. So maximum power will be produced. And that's why sometimes if they are not oriented very well at your homes, you'll find that the power that they are able to generate is little. And that's what we are going to look at in today's session. We are going to look at what is the mathematics behind the solar powers, the solar panels. Now, this is just a simple application. You don't need to write. But what I wanted to show you is that when the things we are going to look at today are going to be rotating at the dot product. And in our daily lives, one of the applications for these dot products is on how the solar panels are always set. That when they are setting them, they must ensure that these panels are set in a way that the angle between the solar panels and the rays coming from the sun is maximum, such that you can be able to tap the maximum amount of light from the sun rays. Otherwise, if you don't do that, you'll find yourself that you are unable to get maximum light. So there are some calculations they usually make before they put those solar panels, and that's why they tell you that they should be slanting. So that king thing of slanting is to make sure that the angle between the rays and the angle between the sun rays coming at the same like the angle is good enough for this for it to be able to support the tapping of the sunlight. So when you are expecting scenarios, we shall have scenarios coming from this area because it is one of the applications. Other applications we are going to meet is that many times when we talk about dot product in simple terms, I want to put it like to put it in easy words, is that how much is your effort valued in the process? That's what you call dot product. So dot product simply means that how valuable is your effort. You may be doing the work, but when your effort is negligible, so that is what you call dot product. So dot product is just about how useful your pushing effort is. That's what we call the dot product. And you'll find that the dot product, like here in industries, you'll find them, it is being applied. So you'll expect scenarios also originating from this area. When you look at my screen again, I have these photos, and I'm going to write different letters. This is going to be my photo A, this is going to be my photo B, this is going to be my photo C, and this is going to be my photo D. I'm going to ask you to tell me which person do you think is going to like which photo demonstrates maximum use of the effort, like where do you think the effort is useful. And like in order for your effort to be useful, one, you must be able to push in the same direction, and you must be also going towards the same direction. Otherwise, if you are pushing in a wrong direction and the object is also going in another direction, you find yourself that what you are doing is wastage and there is no. So if I may ask, you can put in the chat if you have found that people are saying it is A. Very good, very good. Now there are three scenarios I want us to take. One, if you are pushing in the right direction and the object is moving in the right direction, then we shall say there the dot product is positive. That is where you expect maximum dot product. So that means that for picture A, since the direction is the same and the person is pushing the right direction, that is what we call the dot product is positive, and there it is large. It means that your effort is much valued. But when you look at picture B, the person is pushing the right direction, but this one, the object is moving this side, but the effort the person is pushing in the sideways. So whenever you push something in the sideways, what's going to happen? Right, this object is going to move, but the movement it's going to make is going to be small. So here we shall have what we call small dot product, that your effort will be valued, the object will move, but it will move at like as a small distance will be moved. Then when you look at this one at part C, you can notice there that the person is pushing, but there are side, like this one is like the person is pushing this side, something is going upward. So that means that here the dot product is going to be zero. You are wasting effort, you are wasting your energy. Then when you look at the last one, you notice that the object is moving in another direction, the person is also pushing, so they are opposite to each other, and this is what we call the negative. So whenever you find that your dot product is negative, it means that you were pushing in opposite side. So you are wasting, instead also you are wasting your energy. Kindly let me know whether the concept is you have picked something from what you call dot product before we dig deep. Mhm. Okay. Okay, people have picked. So, in simple terms, dot product measures how much one is force, the direction, helps something in another direction. That is the kind of thing that how much is your effort valued? We are looking at the effort. If your effort is useful, then we say that is the positive. If your effort is useless, then we say that is negative or zero. So dot product in simple terms for you what you need to understand for a layman, in case you are explaining to someone, to a baby, you tell them that that's what we call useful effort. That is what we call useful effort. And you have noticed that in order for us to get useful effort, for your energy to be useful, it means that you must be pushing in the same direction, or you must be going to the same point. So that is when your effort is going to be very useful. So that's what we are going to look at today. And the scenarios we shall be looking at will be rotating around that area. Okay, so we are good to go. So now by definition, oh, Esther has something. Yes, Esther, ask.
Good morning, teacher.
Good morning.
I just want to clarify. So, apart from A, the rest are negative dot product.
Mm.
Oh, okay. Thank you.
Come again, Esther, you're saying?
Apart from A, the rest are negative.
Oh, not really. Like, let me come again. Like the negative one is this one, whereby we are pushing in the different direction. You are going this side, another person is going this side. Then this one, it is positive for this B. It is positive. But the only difference is that for the movement is going to be small. The movement, like if you have, let me say this is your object, someone, if this is the direction the object is taking, and you are like let me say this is 3 Newton force and this is 3 Newton force. If all of you are pushing, you are pulling the same direction, the object is moving the same direction, you'll move quickly and you'll use less energy. But this one that is pulling sideways, right, the object is going to move, but it's going to be small. So here the dot product is positive but small.
Okay, thank you so much, teacher.
Then here, because the object is moving like this, you are moving like this. Here it is zero. You are not going to go anywhere. That is the meaning. That one is moving this side, another one is moving this side. So you find yourself, you are almost in the same place. So here it's going to be zero. Then for this one is the one that is going to be negative. The direction is going this side, and for you are pushing this side. So you find yourself that you are in the opposite direction.
Wait, I've answered, teacher. Thank you.
Okay. Ano? Sorry, unmute again.
Good morning, teacher.
Morning.
Teacher, some of us have just joined the meeting and we are kind of lost.
Okay, well, you are going to pick up from here because this is where now we are going to start from. But in simple terms, we are asking or we are explaining that dot product mainly means useful effort. And I've demonstrated the different scenarios where we apply these dot products. But now from here, you follow up, you are going to be able to catch up from here. The only thing that maybe you are going to miss out is going to be on the applicability of it. But from here, you are going to be able to catch up from this point. Now, members, when we talk about the dot product, like we have said that for your effort to be useful, the two things I want you to pay attention to, that you must either like be going in the pulling in the same direction, like this. When you are pulling the same direction, something will move. Or you must be pushing towards the same point. So whenever you are going to be dealing with these dot products, when they give you the vectors, make sure that when you are drawing your vector diagram, the arrows where your angle is going to be formed is having arrows pointing towards it or arrows going away from it. So either the direction must be parting ways or the direction must be moving towards each other. And by definition, when we talk about the dot product, this is what we mean by the dot product. Dot, like the way you hear the word dot, B is always given by the magnitude of the vector of the two vectors times the cosine of the angle between them. So this is by definition. And this is what we are going to be using going forward. So may I ask you to first take note of it and then we start. So the directions matter a lot, the angles, and it is this one. Okay, first write and then you let me know and then we start. So when you finish, you let me know. But what is important is you knowing this and then the definition. And theta is the angle between them. Is it the same as multiplication? Yes, but here we use the dot. And the way we multiply is a bit different. These are vectors. Mm. Mm. Though one of the assignments, in case I forget, is going to be that these dot products, I know you looked at cosine rule. You can use it if you want to prove the cosine rule. In case you want to prove things of Pythagoras theorem, you can use it as well. So it is very important in those things. Okay, I'm going to wait for you. But once you finish, you let me know, and then we start. Okay, people have finished, so we are going to continue. Now, what do I want you to know? Like we have said, in vectors, when it comes to vectors, we have what we call the unit direction vectors. Like we looked at I, we looked at J, we looked at K. Now, what happens is that you know very well that if I have, like I remember telling you, I think, that this is I, this one can be J, this one can be K. Please, I told that it doesn't matter. I know some of you may say, I want this one to be I, this one to be J, this one to be K. It doesn't matter. Even if you want it like this, you want it like this, that this is your I, this is your J, and this is your K. It doesn't matter. Number two, what you need to know that always the angle between them, the angle between this is the angle between those different things. Here, between the I and the J, we shall know that that angle is around 90 degrees. So, what is important, I want you to take note that whenever you are having the cos, let me say, we have said that from definition, A dot B is magnitude of A, magnitude of B, cos of theta. Now, in case I have I and J, let me say these are vectors. Remember, these are vectors. So this is I dot J is equal to magnitude of I, which is 1, magnitude of B, which is 1, cos. But the angle between the I and the J is 90. So you know very well that cos of 90, when you place your calculators, cos of 90, what do you get? Cos of 90. Do you get the answer I'm getting? I want you to tell me what you're getting. Place cos 90. You get 0. So that means I dot J is equal to 0. So going forward, I'm going to just quote that whenever you multiply or you dot I dot J, you get 0. When you dot, members, now you tell me, What if you dot j dot k? Members, what answer do you get? J dot k, which answer do you think you'll get? Aha, very good, very good. So I'm going to just now tell you that when I have I dot j, here we shall get 0. Whether you have j dot k, you also get 0. Whether you have, which one is missing? I dot k, still you get 0. The moment you dot any two directions, I, j, j, k, and the rest of that, you will end up getting what? Getting 0. Hope that is okay, members. As long as you are dotting any two different vectors, you find yourself that you are going to end up with zeros. So please take note of that. And if I may ask, what do you think if I dot I, what do you get? Like, Samsung has said you get 1. And how does this one come about? We know that A dot B is equal to magnitude of A, magnitude of B, and here we have cos of 90. Sorry, cos of 0. Because you know that if you are dotting the same directions, the cos is 0. So you'll end up having I dot I is equal to, you know that the magnitude is 1. So when you dot I, you end up with 1. When you dot j, you end up with 1. When you dot k time dot k, you end up with 1. So please know that j dot j, you get 1. K dot k, you also get 1. So members, let me know whether that one is clear and we are good to go. Dotting is very important. Okay, Imran has a question. Okay. Yes, Imran.
Good morning, sir.
Morning.
I was kind of distracted, but I'm requesting for a pardon on when you said that I dot I is equal to 1.
Oh, like we said, from our definition of a dot product, if this is vector A, vector B, cos of an angle. Now, I dot I means that where there is A is the vector I, dot I. And we say that these are unit direction vectors, meaning that their magnitude is 1. So this is 1 like times 1. Then the cos, since they're in the same direction, there we shall have our cos as 0. So here we shall have the angle as 0. So you'll notice that here you'll have 1 times 1, which gives us 1. So that's why I dot I gives us a 1.
Isn't it a 0 because if the angle is 0, don't you multiply by it to get a 0 also?
Okay, you place, remember you are substituting where there is theta. So what is cos of 0?
Oh, it's a 1.
Yes. And we say that this one means that you are going in the same direction. So your effort is useful, is maximum, is the greatest. Yeah.
Thank you,
Okay.
sir.
Okay. Okay. Lastly, Esther.
Okay. Teacher, I understood for I dot j how it's
Mm.
0, but I don't
Mm.
understand why j dot k is also 0.
J dot K. Like we said, when you come back here, this is like your I, this is J, and this is K. Are you seeing?
Yes.
So the angle here is what? 90. So when you substitute I dot, which one do you want? J dot
J
K
dot
here. So you'll have J dot K is equal to magnitude of J, magnitude of K, cos of 90. So cos of 90 is 0. So everything here vanishes. So that's why J dot K is equal to 0.
So is the angle between I and k also 0?
All these angles, as long as we are between two different directions, everything will be 0.
Oh, okay.
As
Thank you, teacher.
or you can take it that whenever, what you need now to know that whenever you dot anything that is any directions, ki, you dot I, j, jk, everything you get, you end up with 0.
Okay, thank you so much.
The ones that give you a 1 is only I, j, j, and kk. Okay. Yes, Brian.
Teacher, meaning that when we are handling that of I,
Mm.
the movement, like
Mm.
we consider the cost to be 0 because the movement was not a dot. Because I see when we are replacing for theta, we used cos 0.
Mm.
So now how do we get the cos 0?
Like
Because
we
me I
have
see.
said, means that you are more like this is where your force is going. This is the direction for your vector, and this is where you are pushing. Are you seeing? When you are measuring
Yes.
angles, an angle along a straight line like this angle is going to be 0. Because remember, when you are measuring, you measure like this. So here I. So I will multiply 2.1. 2.1. Then I multiply 1.3. So what am I going to get? 2 times 1, I end up with 2. 1 times -3, I end up with -3. And therefore, I'll conclude that my A dot B is equal to 2I minus 3J. This is the first approach. Sorry. In fact, I need just a minute. Let me repeat. I'm saying that we have A equals to 2, 1, and I have B equals to 1, -3. Now, when we are dotting, I can write it in this form that 2, 1, dot 1, -3. Now, when you are dotting, you dot 2 and 1. So I will say this is 2.1 plus 1.3. What am I going to get? 2.1 is 2 plus 1.3 is -3. So I will end up with -1. Alternatively, that is the first approach. Alternatively, someone will say A dot B is equal to 2I plus J dot, here is going to say I minus the 3J. Now, when you are dotting, you dot the I's and the I's, the J and the J's. So that means that you can say 2I dot I plus the j dot -3j. Now here, when you are dotting, there is no need for you to say I dot j. Why? Because I dot j is already 0. So there is no need for you to do like that. But you know that I dot I is a 1. So that means you'll have 2 dot, or 2 times 1, then plus I times, j times j, which is a 1. Then you say this is 1 times -3. So you end up with 2 plus -3, which is going to give you a -1. So that is how you can do it. So you can either use this approach or use this approach. Any approach that is easier for you. Hope that is okay. Okay, let me first pick a hand from Faith. Yes, please.
Morning, sir.
Morning.
I just wanted to know at that step of dotting, like
Hmm.
multiplying 2.1 plus 1.3. But if I just multiply them internally, then I put the answer down, like from step 2, I got direct to step 3. Is it okay?
It is well. It is
Okay,
okay.
sir.
Even if you don't show this, yeah.
Okay, thank you, sir.
Okay. Have Faith.
Good morning, sir.
Morning.
So I have a question.
Hmm.
Here in the definition, we said
Hmm.
it's the product of the magnitude and the cosine of the angle. Don't we
Hmm.
need an angle here?
Oh, now here, for this case, because they have not told us to get the angle, we don't need it. They wanted us to just dot, but we are going to look at a scenario of that nature.
Okay. Thank you, sir.
Okay. Okay. Shafi.
Mister. Yeah, good morning, Mister.
Morning.
Yes, I beg you for pardon on this number for real. I'm not getting that dot.
Okay. I'm going to do a number. I'm going to do a number. Okay. Members, let me know through the chat. We are going to do another number. Let me know through the chat whether we can continue. Are we good to continue? Okay. Okay, we are going to work on this. So which approach should we use? 1 or 2? Let me know through the chat. I want to do 1 such that we can be on the same page. Okay, people saying 1. Okay, but use any you want. So when I look at the first one, they asked us to get A dot B. That is the one we are going to work on. A dot B. That is the one we are going to work on. But let me first give you an opportunity to first try out on your own. Let me first give you an opportunity to first try out on your own. First try out on your own, and then we see. What I can do, I'll come here, I extract my A, which is 3, 4, negative 1, dot my B, which is 2, 3, and a 1. So when we are dotting, I dot 3 and 2. So this is going to be 3 times 2 plus 4 times 3 plus negative 1 times 1. So I'll end up with 3 times 2, which is 6, plus 4 times 3, which is 12, plus negative 1 times 1, which is negative 1. So this will be, now you add everything, which is 6 plus 12 minus 1. So you end up with your 17. So members, can we at least try out part 2 and part 3? Okay, as I pick Salima.
Good morning, sir.
Morning.
Teacher, is it a must to add?
Yes. Now what happens is that whenever you multiply a vector times a vector, you end up with a scalar. So that's why we add. A vector times a vector, you get a scalar.
Okay.
Okay. Who is doing for us
Thank
part
you.
2? Okay. Yes, Brian?
Teacher,
Yes.
like I'm going to try part 2. So we are finding for A dot C. So this equals to, we list out the values of A, which are 3, 4, and negative 1. Then we dot for C, which are 1, 2, and 3. Remember that when we're handling this number, we multiply the values of I alone and J plus those of K. So for I, we have 3 times 1, or 3.1. Yes, then plus 4 times 2, then plus negative 1 times 3 times 1. Like I'm still here using a calculator so that I don't give out a wrong answer. And the answer is 8.
Okay. Thank you. Thank you. Debbie?
Good morning, sir.
Morning.
I want to do Roman numeral 3.
Okay.
I'll list the values for B, which are 2, 3, and 1. Then dot the values for C, 1, 2, then 3. Then I multiply 2 times 1 plus 3 times 2 plus 3 times 1. 1 times 3. Then there we shall have 2 plus 6 plus 3, which gives a total of 11.
Okay. Thank you, Debbie.
That's okay.
Okay. That is correct. Members, are we on the same page on that? Anyone we are leaving behind? Dr. Peace?
Morning, sir.
Morning.
Is it okay? I want to try part B.
Okay, part B. Okay.
So they want the angle between the vector A and B. So, the formula, you first write down the formula for the finding the angle as cos theta cos.
This is the formula, right?
Yeah, all right, it's the same. So we have to find the dot A dot B. So we have to pass the values of A.
Okay. Dr. Peace, should we just quote from here?
All right, it's already there. So we can now get the magnitude of A.
Okay.
So magnitude of A equals to root over 3 squared. Okay, that is the general formula. Then that is equal to root of 3 squared plus 4 squared, then minus 1 into bracket squared. So that is 9 plus, let me try to press the calculator. 9 plus 16 plus 1. So that's root 56.
Add again. Root of?
Sorry, 9.
Root
9 plus 16 plus 1. That's root of 26.
Root of 26. Good.
Then we go to units. Root of 26.
Root of?
Root of 26 units. Oh, it's okay.
Okay.
We don't put units.
It is very well as well.
All right. So we go to magnitude of B.
Okay.
That will be 2 squared plus 3 squared plus 1 squared. So that will be 4 plus 9 plus 1. That's root 14.
Okay.
Then we come back to our formula. We substitute the 17, which is the A dot B, equals to our magnitude of A, which is root 26, times the magnitude of B, which is root 14, cos theta. So we have to divide through by the two roots that are multiplying themselves. But let me get the final answer there. Root 26 times 14, it will be, that's root 364.
Okay.
So it's 17 divided by root 364. I will get cos theta equals 0.8910 to 4 dps.
Okay.
Then we shall get the cos inverse of that. The cos inverse of the answer will be 26.99. No, it will be 27. In fact, if you round off 27
Okay.
degrees. So we can now maybe conclude that the two vectors are not perpendicular. In fact, they are parallel because the angle is not 90 between them.
Okay. Okay. We shall look okay. Thank you, Dr. Peace. So we shall at this point you may not be able to conclude on the nature of the type, but here you just said that the angle between the two vectors is 27 degrees. Members, kindly let me know through the chat whether we are understanding the concept. Whether we have understood or whether there is any understood. Yeah. We should not leave any. Okay, people are saying it is all fine. Understood. Okay. Let me, Chobe, is it a question? Okay. Chobe. Okay. Chobe, I'm going to mute you. Miracle, is it a question?
Yes, teacher.
Okay.
So my question is,
Hmm.
like, why do we first get the cosine 17 out of root 364? Shouldn't we just get the cos inverse from there?
Oh, you can. You can as well do so.
But when you do so, you don't get the same answer.
How did you do it? You did 17 divide
From there,
by. Hmm.
I did cos theta is equal to
Hmm. Hmm.
17 divided by
Mm-hmm.
root 364.
Mm-hmm.
But then I said theta is
Hmm.
equal to the cos inverse of
Hmm.
17 over
Hmm.
364.
Over
I
root.
punched, yeah,
Uh-huh.
I punched it in the calculator
Uh,
and I got
eh.
0.4711.
Hmm. Now, you are going to check your calculator.
Yes,
Hmm? Your
yes.
calculator looks to be in radians. If you are getting 0.47 something,
Mm-hmm.
your calculator, so you change it from radians to degrees.
Okay.
Hope you know how to change it.
Yes.
First change it and then you let us know. And members, please always check out whenever you get such awkward answers for the angles, always try to check out. Many times you may find your calc is in radians. And you know that when you work out things in radians, you may find that any trigonometric number, you are going to have it wrong. Should you work with radians? Yes, Justin.
Teacher, it is the same.
It is?
It is the same.
Oh, okay.
Thank
Okay.
you, sir.
Okay. Yes, Justin.
Good morning, sir.
Morning.
I'm going to take you back to part A.
Hmm.
My is that, okay, I'm a bit confused. Why,
Hmm.
okay, after multiplying, we further go on to add. Like after, what, like let me say A dot B there, back there, we multiplied the I and I, J and J and K and K. So why do we go on to add?
Yes. Sorry about that. I don't know what happened to my network, but I was just in first come again.
I was asking,
Hmm.
in part A, like after multiplying, let me say you multiply I and I, J and J,
Hmm.
K and
Hmm.
K. I'm still confused on why we continue to add, like the reason.
Why we add
Yes.
one is that when I have 2 and 3 and 4, okay. One is that when I multiply I times I, the result I get is a scalar. A scalar is just any value. So let me, here you'll get 1. Let me say you get 1. So when I multiply 3i then times 2i, I'll end up with 6i squared. But I squared is 1, so I end up with 6. Now, we say that dot product is like the combined effort. Like you are going to combine all the effort. So you want to know how much of that effort is going to be useful. So that's why now we add. We add the ones that we had taken in the I direction, the J direction, and then the K direction. In other words, you are trying to bring all the components to be facing one side. So that's why now we keep on adding.
Okay. Thank you, teacher.
Okay. So I think we are going to proceed. I want to first give a question. As people read through, let me be answering. Arnold,
Yes, good morning, sir.
morning.
Actually, I was inquiring why we used cos theta.
Oh, why we use... okay. Let me first disable this person. Why do we use cos theta? Now, cos theta, we shall look at, I don't know whether I will be able to show you how it comes about. Do you remember the cosine rule?
Yes.
Now, this particular aspect has some origin, has some aspect from the cosine rule. That when you want to find the angle between any two things, if you remember how the cosine rule came about, but maybe, okay, maybe at one point I'm going to show you how it comes about, why they use the cos.
Yes.
Okay, but you can relate a bit to the cosine rule when you want to get the angle between two.
Yes. Okay, sir. Thank you.
Okay. Yes, Gloria?
Teacher, for me, I was kindly requesting for the conclusion of part B.
Part B. Oh, it's just you can say the angle between the vector A and B is 20. I don't remember what it was, but it was 20 something.
27.
27.
Okay, thank you, teacher.
Okay, thank you. Yes. Namata?
Okay, sir. For me, what I'm asking, isn't there another formula for part B? Another way
Not
of
really.
getting the answer?
Not really.
Okay.
Okay. Okay. Yes. So, uh, okay. So let me hope members are trying out this. I'm expecting you to be now trying it out. Now, I'm going to be throwing some light on the angle. I'm going to be throwing some light on the angle. This is just, I'm just doing this to help my brother who asked why we use cos. Now, like we said at the start of this, that when we are looking at dot product, we are looking at by how much of vector A is pointing along B. That is now what we look at. But how much of A is pointing along? So when you go back to the issues, you remember in your, I think you did some resolving. You did some resolving somewhere. Now, what we call the length of A, the length of this A, if you remember very well that the length of A, or what you call the length of A in the direction of B, is always given by the magnitude of A, then the cosine of the angle. But this one, I think you did it in the dynamics 1 when you are looking at the resolving bit of it. That if you want to get to have this one, to have this force A projected along A, along this point here, we use what? The cos. So that's where it is originating from. That I didn't want to show you, but maybe towards the end of the lesson, I'll show you how it comes about. But if you remember that, that is where it comes from your dynamics 1. So let me hope people are trying out this, and I'm going to look at the chart. So they told us that we have a structural engineer that is fixing 2 cables at a construction site. The direction of the cables are represented by vectors AB. For the structure to remain stable, the cables must be fixed at an acute angle to each other. Using vector methods, determine the angle at which the 2 cables should be inclined for stability. So here in simple terms, they're asking you, what is the angle between those 2 vectors? So I'm expecting you to go on and get the dot product between the 2 vectors. So remember, to get the angle, you need 2 things. So I expect to say that A dot B is equal to magnitude of A, magnitude of B, and then the cosine of the angle. So the first thing I want you to get is that first find out what is A dot B. Then find out what is the magnitude of A and what is the magnitude of B. Once you get those ones, it means that now you'll have the angle. And here, remember to remain accurate. When you get a square root that is not a perfect one, please go on and first leave it in a square root form. Don't go on and get what? And get points. Yeah, because the more you get the points, the more you divert away from the answer. Okay, I'm seeing some answers coming in the chat. Okay, I don't know, people who are getting 31. Remember, for angles, we can write to at least 1 or 2 decimal places. The other time we wrote to only 0 decimal place. The reason was because we are getting 9995. So when you round off, that's why we went to the other side. But it does not mean that we must write the angles. When we get decimals, we must get okay, okay, okay. Okay, the answers I'm seeing in the chat are okay. Anna, do you want to take us through? Okay. Toshiba?
Good morning, sir.
Yes, good morning.
So, like as we've written our formula, because they said we determine the angle at which the two cables should be inclined for stability. Then we have to arrange them like, because we need to get A dot B. Then our A is 1, -3, 3, dot -1, -3, 2. And then we get our 1 times -1, -3 plus -3 times -3 plus 3 times 2. We get 14.
Oh, the answer here is 14.
Yeah, 14.
Okay.
Then we come to our formula and we substitute in.
Okay, what about magnitude of A?
The magnitude of 8, because our 8 is 1 squared plus 9 squared. No, plus 3 plus -3 squared plus 3 squared. Which is, because if I add 9 plus
19. Oh, I think I'm losing you on your network.
19,
Okay.
Then
Okay.
the
So
magnitude
members
of
that
B, yeah, it's 14.
Okay. Oh. Then here you do your mathematics.
The
You do. Okay. Thank you so much. So here do your mathematics members and come up with the answer. Do your mathematics and come up with the answer. So according to mine, I'm getting 30.9 degrees. And then therefore you make a good conclusion that the angle at which the two cables should be inclined for stability should be 30.9, 30.86. Yeah. Okay. Members, I think. Okay. Okay. I think we are good to go. True, false? Yes, Audrey?
Teacher, I have a question on that magnitude of B, where according to our question, it's like our x is -1, not 1.
Here.
Yes.
Okay. Thank you, Audrey. Hope the answer remains.
Doesn't it now become root of 12?
Root of, okay. Audrey, what is -1 squared?
1.
1. -3 squared?
That is 3.
No, you square
Sorry,
negative.
-3. Oh, that is a 9.
Plus the 2 squared.
That's a 4.
So when we add?
You get 14. Okay.
Okay. Thank you. Okay, so I think we are good to continue. I have another one here. They are telling you that relative to the origin, the position vectors of point A and B are given by this. Find the angle. Now, for such, it is very important for you to come up with a sketch first before you do any other thing. Because it's not just that you are going to like to multiply. that you are going to multiply O times A, O times B. Why? Because you may get an angle that is not the one in between. Because when you look at this, you are noticing that the angle they are interested in, the angle must sit at B. That means that when you are coming up with your sketch, any sketch you are going to come up with, one, we say that in dot product, the direction, the angle must be pointing towards the same point, or they must be going away from the same point. Now your sketch where you are going to have B, you must ensure that the two arrows are either coming towards it or going away from it. Not one arrow coming, another one going. Hope that is okay. So may I ask you, before I draw my sketch, you first come up with your simple sketch when that thing is put into consideration, whereby all of them are going towards or all of them are going away. First come up with that sketch. But you must make sure that where your angle is sitting is where we have our B. First come up with that sketch, everyone, before I draw mine. I'm going to draw mine because that's what is going to determine which ones are you going to dot. You don't just dot anyhow. I give you a minute. When you finish to draw your sketch, you tell me done. And then I draw mine and then we compare and see whether we are on track. Draw a simple sketch. And when you look here, they have given you 3 letters OBA, meaning that your sketch is going to be in form of a triangle. Okay. So some people have come up, okay, done, okay. Now let me also draw. Now I'm going to draw my triangle. The way you see here, this is my triangle. Now, this is my B. I can first fix B as my angle. That my angle is at B. This is where my angle is. Now, then after, I can fix O and I can fix A. Anywhere, no problem. Hope that is okay. So I can fix my O, I can fix my my A. Hope you are not seeing. So what does it mean? What does it mean? It means that O, I have O to B here already given. So my arrow will face like this. Then I have O to A. O to A is facing like this. You are not seeing. That means that in order for me to get the angle B, our arrow, where should our arrow move from? From which letter to which letter? Members, tell me in the chat quickly. From which letter to which letter if we are to get the angle at B? On to B. A to B. Very good. So that means that your arrow must be pointing from A towards B. So that's when we can get. Now, members in the chat, you tell me which two vectors do we need to dot? Which two vectors do we need to dot? Put in the chat what you think. Which two vectors are those that we are going to dot? Remember, those two vectors must be moving towards where we want our angle to be. We are going to, very good. So the two vectors we are going to dot, members, we are going to be dotting these two vectors. We are going to be dotting OB, O to B, and we are going to be dotting A to B. Those are the vectors. That's why you shouldn't cram, read the question. Read the question. So when you look here, it means that, members, you need to first know your vector O to B, which is already given here. Number 2, we need to know what is our vector A to B. A to B, A to B. And by definition, who's taking us through a B? We have already looked at this. You ask yourself, how do we get A to B? Anyone to take us through how to get a B? Okay. Okay, let me first take on Juliet. Yes, Juliet.
Okay, so to get AB, we are going to get OB minus OA.
Very good. OB minus OA. Continue.
So OB, we have -1, 3, -1, minus 5, -2, 4. So we subtract the I with the I. So -1 minus 5, 3 minus -2, and -1 minus 4.
Okay.
There we get -6, 5, and -5.
Okay.
That's
Okay. Thank you, Juliet. Thank you, Juliet. Let me hope that is okay to everyone, how we get A to B. Now, when we are going to write our formula, let me ask Kate, give us the formula we are going to use to find the angle.
Teacher,
Yes?
I may have a question.
Okay.
I'm going to take you back where you decided that our arrow should be from A to B.
You have not yet?
Like where you said our arrow should be from A to B after us
Oh,
drawing the.
like I said earlier on, when we are looking at dot products, we say that the angle, when you are defining, like these arrows must, like, for you to be able to move, to maximize, you must either be moving you must be moving towards the same direction, that your object and your force must be pointing in the same direction, or you must be going away, pulling in the same direction. So that's why that in order for you to get the angle between, you either come towards it or you are going away from it. That's when you can be able to move something ahead.
Okay, teacher, it's clear now.
Because if this one is coming and this one is going away, you are going to waste energy and effort. Hope that is okay. Okay. Ivan, do you want to give us the formula?
Yes.
Okay, give us the formula to use.
For the formula is A dot B. A dot B dot B equals to magnitude of.
Ivan, which vectors are we dotting?
I'm going to substitute. Okay, let us use those very ones. We are saying that OB dot AB is equivalent to magnitude of OB magnitude of AB cos theta.
Cos theta. Very good. Very good. So members, let me hope that is what you are using. Ronald Matov, you can unmute. The rest, let's complete. Matov, have you got some answer?
We can first dot OB with AB.
Okay. OB dot AB, what do you have?
I'm having -1 3 and a -1 dot -6 5 and -5. Then we multiply the I components. You're having negative, you're having 6 plus 15 plus 15 plus 5.
Okay.
You're having 26.
Okay.
Then we can first find the magnitude of OB. from square root of negative 6 square, negative 1 squared plus negative 2 squared plus 4 squared. That is 1 plus, you're getting 11, root of 11.
Okay.
Then magnitude of AB, which is under root of negative 6 squared plus 5 squared, then plus negative 5 squared. 36 plus 25 plus 5, which is root of 86.
Okay.
Then we substitute in the formula.
Okay.
Where there is OB dot AB, we're going to put 26. Then root of 11 cos theta. We can first multiply the components under the root.
Okay.
Then 11 times 86, which is root of 946. We can divide both sides by root of 946. Then theta will be cos inverse of 26 out of 946. Which is 35.6276.
Come again.
35.6276 degrees.
Check. There is something not right.
35.6.
35, I'm getting 32. And also in the chat, I saw 32.
Okay.
Okay. I saw quite a number of answers in the chat, but the following people, at least I saw your answers were okay. Earlier, that answer was okay. Samsung, it was okay. Steven was okay. Patrick, Rachel, Martina, Jovix, Steven, Hudson, Debbie, Chizal, yes, Doi, Judith, Toshiba. I think those answers were okay. Let me pick on some few hands. Yes, Joan. Joan? Oh, sorry, Joan, come again.
Good morning, sir.
Morning.
But I'm not understanding the number. I could see that maybe you pardon from the beginning.
Oh, which part? Which part mainly? What is confusing you?
Yeah, the whole of it. I could see that you pardon.
Okay, Joan, do you know how to get the magnitudes?
Yes.
Do you know how to dot?
Shall maybe pardon from there?
Okay. Let me see how I'm going to summarize it. Let me first also pick on Brian. Yes, Brian.
And now, teacher, my question is,
Mm.
can't we, if we interchange the method, when we start off from finding a dot b, after finding the magnitude of fb, Yes?
It is okay. You get the same answer.
Okay, then I thought that it was not allowed.
Oh, it is okay. If you start from ab.ob, it is the same answer.
Okay, teacher. Thank you, teacher.
Okay. Doctor, please.
Teacher, I just want to inquire that when you have reached to get the final answer, which number of DPs is suitable to round off to?
Okay. For angles, in real sense, okay, in real, one dip, you first write to your 2 DPs and then you can write 1 DP.
Okay, sir. Thank you, sir.
Okay. Now let me first summarize for I'm going to just summarize for the last, and here do not forget that in your conclusion, you are going, and here in the introduction, you say, let my angle OBA be theta. But if you did not mention it, then at the end of the day, please do not forget to conclude that the angle OBA is this. Then just let me just throw some light. Like we say that when we are dotting in like in vectors, if you are dotting, if this is a vector A and this is vector B, in order for you to get the dot products, you must ensure that the arrows are coming from that point. This is where your angle is. In case that's not the case, let the arrows be facing each other. Let them be going to the common point. So that is very important. So for any sketch you are going to come up with, even for this number, even if you had come up with a sketch where the arrows are pointing away, that is also okay. You get the same answer. What is important is to make sure that all the arrows, the 2 arrows that are forming those vectors are coming from a common point or they are coming towards a common point. Then for our sister who asked, we say that the first thing you have to do, come up with a simple sketch. Even if you just say this is O, this is A, and this is B, it is very fine. What is important is for you to ensure that arrows are the angle you want. This is the angle we are interested in, angle B, that arrows are going that side. So in simple, what you can do, first have your arrows pointing towards that. Then you figure out the rest. Have your arrows pointing towards that. That's the first thing. Then you can figure out the rest. So now here you know that I'm going to have O to B, which you can O to B, and I'm going to have A to B. So that means that when you are looking at any other thing, that is what you have to look out for. That you are going to look at OB, which you already have, and then you look out for this one, this second vector, which is A to B. So what you are going to dot here, you are going to dot this and you are going to dot this. So that's how you do the dotting. And we say that when we are dotting, people preferred this approach. We say that in case this is 1, 2, 3, and this is maybe negative 1, 2, and 3. This is I, this is I. So just multiply these two. 1 times negative 1 plus multiply these two here as well, and also multiply these ones down as well. Okay, that is the simple summary I can offer for now. May I ask you people to take a screenshot of this as part of your exercise? Okay. Okay. Hope members have finished. Finished? To take a screenshot? Okay, we can start now. Okay. Now, I am seeing a question. Okay, as people read through. Yes, Audrey.
Teacher, when you are making, just sketch the other side on the part, okay, of the direction of AO over OA around there. What did you use to determine its direction? can it, instead of it going up, can it go in any direction as long as I have determined that these ones are pointing to the angle I want?
Yes, even if you do it like this is, let me say, O, B, and this is A. Even if you do like this, it is also okay.
Then the angle for OA, can it go in any direction?
Like which angle are you finding? That is what
Rather,
is important.
that arrow.
No, like which angle? Because where the angle you are finding is what determines where the arrows are going to point.
Mm-hmm.
So in case I want angle OAB, are you seeing angle OAB? If
Yes.
I'm interested in angle O to AB, then it means that when I draw my diagram, like this is OAB. Everything must come towards either A or go away from A. So either I can say my arrows must point like this. Alternatively, all my angles, they can go away. If I'm interested in angle at A, if I'm interested at an angle at O, let me say O. It means that I will draw my diagram. This is O, this is A and B. So we said that at O, this is the angle. Remember the letter in the middle is the angle of interest. They can come towards. That means you have to dot A to O and B to O. Alternatively, they can go away. So you dot O to A and O to B.
So teacher, what I'm saying is that the arrow for now, let's say, if I'm finding O, and then let's say my arrows are moving away from the position O, so where would my arrow for AB go? Can it go in
No,
any
now that
direction?
means, remember, these arrows that are going away from the point of your interest are the ones that determine which vectors you are going to dot. So if it is at O that this is the angle, that means you are going to use OA and OB as your vectors. These two are the ones that are forming your angles. So these are the ones that you are going to dot. So you don't need anything like AB.
Okay.
Okay. So then we have what we call parallel vectors. When you look at parallel vectors, those are vectors that do point in the same direction. And if they are pointing in the same direction, their angle is going to be 0. So, and we know that cos of 0 is 1. So from definition, this is what we end up with. So this one you can just summarize. You can summarize because cos of 0 is 1. So that's why we don't put here a 1. But it comes from the definition that A dot B is equal to magnitude of A, magnitude of B, cos of theta. So the theta is in, yeah. Okay. Let me know whether we can continue. Okay. 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 Then we have the second, what we call perpendicular vectors. Now, perpendicular vectors means that those are the vectors whereby the angle between those two vectors is 90. So the angle between the two vectors is 90. So we know that from definition that A dot B is given by magnitude of A, magnitude of B, and then the cosine of theta. Now, what happens is that since this angle here is 90 degrees, it means that the dot product A is going to be magnitude of A, magnitude of B, and then this cos of theta, we shall say cos of 90 degrees. But we know that 90 degrees, cos of 90 degrees gives us a 0. So that means we have A dot B equals to magnitude of A, magnitude of B, then times the 0. Anything times 0 is 0. So A dot B will equal to 0. So the moment they mention, whenever you are reading a question and they tell that those two vectors are meet at right angles, those two vectors are this, then it means that those two vectors are, you just dot those two vectors and then you equate to 0. That is the meaning. And that is whereby your effort is useless. Yeah, so that's where the effort is useless. For you, I put one person like this, this is the direction and this is the direction. So there's nothing, there's no effort. Your effort is just zero. Okay. When you finish, you can let me know and then we continue. Okay, people, good to go. Okay. So we are going to start with this. So they are telling us that we have two vectors. So people can first read through. I saw a hand up. Okay. So they told us that we have two vectors, A and B, and they want us to find the value of X. If the first condition is if they are parallel, then the second if they are perpendicular. So still we follow the same. We say that when something is parallel, the angle between them is 0. And we say that for vectors that are parallel, A dot B will equal to magnitude of A, magnitude of B. So what do you need to do? The first thing you do is you dot your two vectors. So I'm going to say that my A dot B is equal to 2 and X. I dot it with my, which is 1 and negative 4. You extract your data from here. When you dot, remember as I'm saying, you get 2 minus 4x. Then after I get the magnitude. So when I'm getting the magnitude of A, I'll come and say this is the square root of, we said x squared plus the y squared, which will come and we shall get our x is this 2 and our y is this x. So that means I'll have 2 squared plus the x squared, which will give us 4 plus x squared. When I continue, I'm going to go on and get my magnitude of B. And my magnitude of B, members, allow me to just substitute. I'll have 1 squared plus negative 4 squared, which will end up giving us 1 plus 16, and which gives us root of 17. Hope we are still on the same page and we are good to go. Now, after getting that, you substitute back here. You have A dot B, which is 2 minus 4x, will equal to magnitude of A, which is root of 4 plus x squared. Then you are multiplying it with another root of 17. So let me first pick a hand from Bettina. Yes, Bettina.
So it's what I'm asking is, there is getting the magnitude of A. Like after getting square root of 4 plus x squared, is it okay if you write 2 plus x?
I beg your pardon? Where?
After getting the magnitude of A, and then you get your answer as root of 4 plus x squared. Then is it okay if you write something like 2 plus x?
You stay on, eh?
Yes.
Okay. I want to give you this. Which answer do you think you are going to get here?
You'll get root of 6.
Root of 6. And what is root of 6?
From the calculator. That is 2.449489.
2.4.
49.
Okay, we come back here. What about here?
There. Root of 2 squared plus 2. You will get root of 4 plus. Yeah, root of 4 plus 2. And still you get root 6.
Now I want you to use the other approach you are talking about, what you are saying.
There you will get still root of 4 plus x squared. Then it will remain the same because x squared is non-defined.
No, like there's something you are saying whereby you said 2 plus x squared.
Yes.
I wanted you to apply it here, and then you tell me.
On the 2 squared. Because 2
Does
squared,
it work?
it does not.
It does not. Yes. So what we are saying, it cannot work here because this is addition.
Yes, teacher.
So
Thank
you
you.
just work it the way it is. Okay. Okay. Okay, members, let me hope we are continuing to get the answer. Okay. Now, the moment we reach here, members, what we do is that you can first multiply, in roots, when I have root of A times root of B, these two can multiply and you have one root as AB. That is very possible. So here I can say this is 2 minus 4x is equal to 1 root, where I have 17 and 17 multiplies 4 and the x squared. Now, when you look at what we have this side is 2 minus 4x. Let me say this is root of A and this is 4. So what do? You need to remove this root by squaring both sides. So that is the approach we are going to use. So we are going to do the squaring. So I'm going to square both sides such that we can remove the root. So I'll come here, I square this side. So the moment I square, I'll have this squared is equal to 17 into 4 plus x squared. Hope you remember from your mathematics that root is the same as a half. So the moment you square it, you'll have a half times 2, the 2 cancels. And that's how the root goes out. So once it reaches here, feel free to open your brackets the way you want. You open the way you want. Even this side, feel free to open times 4 plus 17 x squared. Then you do the mathematics here. 2 times 2, you get 4, minus 2 times 4, which is 8x, minus 8x plus 16x squared is equal to, so be complete, 68 plus 17x squared. But let me first pause in case there is someone we are leaving behind. Feel free to raise up your hand. And those who are finished, you can share with us the answer you are getting. In case you are stuck somewhere, you let us know. In case there is any step that is not clear, kindly let us know. Otherwise, here we shall end up with 4 minus 8 will give us our 16, which is negative 16x, then plus 16x squared is equal to 68 plus 17x squared. So what you do now, collect like terms. I will take the 16 this side, I'll take the negative 16 this side, I'll take the 4 the other side. So when I take them, members, you agree that I'm going to get x squared. I'll have this negative 16. The moment it goes there, it will become a positive 16x. I'll take that for the other side. I'll end up with my 64. And everything will equal to 0. Hope we are still on the same page. Hope we are still on the same page. If we are not on the same page, you can kindly... Okay. So Anna, we are saying that for parallel vectors, the angle between them is 0. So the only thing you need to do is come here, dot the two vectors and equate them to their magnitudes. Okay. So let me wait for the answer you are getting. You solve. Use any method of your choice. Angel is getting 8. Angel, can you check? Angel, can you check whether it's actually 8? Salima?
Teacher, I'm lost. Why do we square both sides?
We want to remove the square root. We want to remove the square root. It's like, you stay on. Are you still on?
Yes.
So let me say you have got x squared is equal to 4. How do you complete this number? How do you get the value of x?
Square root.
By? Remember, this is x squared is equal to 4. So you want to get the value of x. Saima, how shall we get the value of x?
We shall square 4.
Square 4. How do we square it? And what would be your answer?
It will be 2.
It will be 2. So you get instead the square root. And therefore you get x is equal
X
to
will
root
be
of 4.
equal to 2.
But now to move away from here, Salima, to come back where you were, that's what we call squaring, that you want to remove this root. So to remove it, you square. You square both sides, such that you can go back where you were. So that's how we can remove the root. Hope you have picked the idea.
Okay, sir, thank you.
Okay. Members, which answer do you have? I'm looking through the chat. People have -8. -8. Matia, check out the one. Earlier, those points, we are not safe. We are not safe. Yeah. So when you solve, you get -8. -8, -8. No, Anna, when you place cos of 0, cos of 0 is not 0, it's 1. So they cannot cancel out. Okay, member. Okay. So we are going to, so here, when you solve, even you can use your calc. Yeah. So here, your value of x will equal to -8. Okay. Now we go to the next part. The next part is the one for the perpendicular. Now, for perpendicular, we say that the dot product of those two vectors should equal to 0. So members, can you find that value of x? Since for me, I've already obtained a dot b, go on and also find that value of x. Quickly, as I pick one hand here. Yes, Chiza?
Excuse me, teacher.
Yes.
Teacher, I've got two answers of x, -8 and -1.
How did you get -1?
I used the bulldozer method.
Yeah. Still, I'm not seeing how -1 comes about in bulldozer. What did you substitute inside?
Was x.
What was your b? Did you have this? -16 plus minus. This was 16 squared minus 4 times 64 out of 2. Was it like that?
Yes.
This gives you -16 plus minus. What did you get inside there?
I just put it in the calculator.
Inside here you get What?
Oh, teacher, I've seen it's only -8.
You get?
It's only -8.
You get 0 inside.
Yes.
Divide by 2, which gives you -16 out of 2, which is -8.
Yes. Okay, thank you.
Okay. 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 So members, I'm waiting to look at your answer. People are getting 0.5, 0.5, a half, a half. Very good. A half, a half. Yeah. Okay. I can now clean my screen. So those who are not getting, do not forget we said that here we said A dot B is equal to 0. So A dot B, we had obtained this. So to get X, just set 2 is equal to 4X and then divide by 4, divide by 4. You end up with a half is equal to X. So that is how you approach that number. Okay, now we can go on and look at another one. Okay, let's look what about when we have 3 dimensions. Can everyone first try it on your own? What about when we have 3 dimensions? Yes, Imran?
Excuse me, sir, on that previous number where vectors are perpendicular, is the answer we get is a 0, right?
Yeah, when you dot the 2 vectors, you get 0.
Oh, so here we do not need to find X.
Here now we need, for this particular one?
No, for the other one.
That one, we needed to find the X.
We do just the same way as we've done how vectors are parallel.
Yes.
But equaling it to 0. Oh.
Yes.
Okay, thank you, sir.
Okay. Yes, Arnold?
Mr. Teacher,
Yes.
for the part of vectors are perpendicular, I've tried getting the answer and I'm getting over 0 out of, okay, X as 0.
For which one? For the other part?
Yes.
How are you? What did you get for your A dot B?
A dot B, I thought it's 0.
No, like when you dot A dot B, what did you get?
So I just substituted that A dot B is equal to 0 since the vectors are perpendicular.
Like that is a condition that A dot B should get 0, right?
Yes.
But what was your A, vector A?
Oh, vector A.
2x, right?
Yes, 2x.
Then 1 negative 4 is equal to 0.
Yes.
So because the question is indirectly asking you, what value, which when you substitute where there is x, you will get your answer 0 when you dot them. So here,
Yes.
remember you're going to dot 2 times 1, which is 2, x times negative 4, which is negative 4x, equals to 0.
Yes.
Then you solve.
Yes, sir. Thank you, sir. Thank you, sir.
Okay. Yes, Martina, go on.
Good morning, teacher.
Morning.
Teacher, you want me to explain how I got my answers?
Yeah.
Okay, so like you told us from the other example, that A dot B for perpendicular is going to be equal to 0. So I put it in column form. So I said A dot B is equal to 2m, m, 8, and then times 1, 3m, and negative 1. Then when I multiplied, I got 2m, 3m squared, and negative 8. Then I added them. I got 3m squared plus 2m is equal to 2m squared plus 2m minus 8. So I equated it to 0. So I used the calc, and yeah, I got m is equal to 4 out of 3, or m is equal to negative 2.
Okay, thank you. So hope that those are the answers we are getting. And remember, okay, and here, avoid writing in decimal points, avoid writing in decimal points. Write it as a fraction, because the moment you write in a decimal point, you are not going to be able to get the dot product as, yeah. Okay, yeah, members, those answers are correct. So we can proceed. Arnold, I don't know that it's a question. I'm seeing your hand up, and Samuel.
So good morning.
Morning.
Yeah, just
Yes? You are saying?
Okay, for that part where A dot B equaling to, if I look at A and B, those are vectors. The vectors that we have been given, they are not labeled. Maybe like it is vector A, vector B. Should I just proceed like that, or I start by first letting them to be?
That is always the first step. First, let your vectors that let the vector A be this. Let vector B be that. So first define them, and then you continue. Okay. Shafi?
Mister.
Yes?
Hello.
Yes, please.
Mister, is there any other dotting? Is there
Yes?
any other dotting? Any other approach
I'm not.
other than dotting?
I didn't
Is
get you
there any
well. I
other
did.
approach other than dotting?
Is there any other?
Approach other than dotting?
To get the angle between two vectors?
Yes.
Okay, another approach we may look at will be tomorrow. But that one, it's a bit, that one is, okay, that one I will show you how to use it. But you need to know all, because it depends on the situation and the scenario you are dealing with.
Okay.
Okay. I think this one we can take a screenshot. But here, the only word I wanted you to see is that sometimes once they tell you at right angles, let it not disturb you. That is something totally different. It means the same. Antonia, you can take a screenshot of this number. You try it and see.
Yes, teacher, I was saying on the previous number, I got two answers. Yeah, I got 4/3 and -2, but I used the curly.
Yes, like when you look here in the question was telling you value of values.
Okay. But it's fine.
Yeah, it's fine.
Okay, thank you.
All right. Okay, let me hope members have taken a screenshot. I have another one here. I think members, I think also this one we shall try it out as well. Have you taken a screenshot of some of these numbers you're going to try out? Yes, Abdu?
Morning, Master. Morning, Master. Master, I was saying that first he put on the previous question, I had not screenshotted.
Okay. Okay, let me go back a bit. Take a screenshot. How do we take? Okay, Samsung now it depends on the phone you have. I don't know that you are using Samsung. Hey.
Basoma live kumacha bakira soma.
Okay, done. Also, this one I think. Okay, that one we have also taken. And then this is, I think, the last one. Hey, I have another one. Hey, so you're going to try out those numbers. You're going to take, maybe this one I can throw some light. When they told us that find here, when you look at this one, they have given us a diagram. They told us that the diagram below with side length 4 units. That means that the length of here, this is 4, 4, 4, 4, 4. All the length are 4 units. Now, they told us that OA, they read for you, the point M is the midpoint of GF. Now, you need to know where is GF. What is what? The mid M is the midpoint here. Remember, if this is 4, that means this is 2 and this is 2. So you must reason that way. Then they told that A to N, what is N? N is here, that this is 1 part, and N to B, these are 3 parts. Now you need to know how to read the vectors. So they told that find each of the vectors O to M. O to M. So I expect you, the first thing you have to do is join O to M. Then remember, we said that when you're writing vectors in 3 dimensions, you must have the I or the X component, the Y component, and the Z component. Because if you don't get these ones correct, you cannot pass this number. So I'm going to ask you in the chat to tell me, what do you think is the vector O to M? Because that is very important for you to be able to do this number. What do you think is the vector O to M? Put your answer in the chat and I look at it. Because once you don't know that one, this number you may not be able to have it right. Remember how we moved when we are starting the topic. O to M. I want you to just be knowing the vectors such that you know how to read them from the diagram. I'm still waiting. I'm still waiting. Okay, people. Remember, now you ask yourself the X component. Are you seeing the X component? This is the X component. Let me read for you one at least. This is the X component. You pay attention to the red one. So you ask yourself, how am I going to reach here? So it means you are going to move along the X. You are going to move like that. I'm going to come here. I can draw something like this. That is one. Hope you are seeing. Then I move like this. I don't know that people are seeing that movement. That I'll move like this, and then I go up. So members, you tell me, what is our I? What is the distance from here up to here? Because those are the things you need to know if you are to read this number. Members are saying that is 2. Very good. This is 2. Members, what about from here up to here? What distance do we have? The next distance. 4. Very good. This is 4 and up here is also 4. So that means that your vector O to M is given by 2I plus 4J plus 4K. Please and take note. Pay attention to the arrows. Now these arrows where they are pointing, those are the positive directions. Should you be moving opposite to those arrows, then it means that is the negative direction. Okay, let me pick, I don't know that, Juan. Yes, Juan. Okay. Yes, Martina. Juan, I'm not getting you.
When I'm looking at OM, I don't know if the movement of like from O, I go to like C,
Wait.
that's OC.
Take me. From?
Okay, if I'm to do, okay, I don't know if it's going to make sense, but anyways. So from O to C.
Good.
Then you cut halfway, like that's half of CB. Then you move up.
Very correct. First tell me, O to C, what distance do you have?
4.
Then this cut?
That's 2.
And then up here?
It's 4 as well.
4. Then you go back. You ask, what is the X movement?
When I'm looking at the red arrow, it's 2.
It is to this one.
Yes.
Then the Y movement?
It's 4. And then
And
the
then the
Z
J?
is 4 as well. It's 4.
Yes, that is very correct.
Okay.
Even someone who would have moved like this, you are also correct. If someone moves like this, please, you are also correct. Someone may say, for me, I want to move like this. Then I move like this, I move like that. That's also okay. Even if you move like this, or you move like this, as long as you have reached the destination, that is what is very important. Okay, then we go to N G. Still, the best thing is to do first connect your N to G. That is the first thing. And then now start figuring out how are you going to move. But why don't you first write for me that one? NG. Eh. Eh. I want you to pay attention to the direction. Imran is saying. Imran, you can raise up the hand. Imran, how would you move?
I think we move from N to B.
N to B.
Then B to C.
B to C.
Then C to G.
C to G. You tell us, what is the X? What is the Y? And what is the Z?
The X is 4.
X is 4. Which direction now? Pay attention to the direction where you are facing.
It's a negative 4.
Negative 4.
Then the Y, it's 4. It's 2.
Pay attention. Look at the ratio. Remember, this was 1, 2, 3.
Oh, it's 3. Then the Z, it's going to be a 4.
Okay, good. Thank you. I want another person to take us through another movement. Thank you, Imran. Mike.
For me, sir, I would take NB.
You would take
NB.
N to P.
Yeah. N to
From
B.
N
To B.
Good.
Then from B to F.
B to F.
Then from F to G.
Very good. Yeah, that route is very, very fine. Thank you, Michael. Yes. Yes. So all those routes can work. Even someone who says, me, I want to move like this, then I move like this, I go like that. That one is also very, very fine. Okay. So members, I'm going to take an assumption that at least now you have learned how to read those vectors such that now other parts can become very okay for you. Yes, Brian?
Teacher, now my question is,
Hmm.
like when we are taking movements, don't we get out of the shape that we are forming?
The shape?
Yes, the shape formed as when we are taking the movements.
No, the shape does not matter. What matters is, have you moved in a straight line and have you reached your destination? But straight line means that you have moved along the I, the J, and the K. That you have moved horizontally, vertically, and upwards. That's what matters.
Okay, teacher, I thought that we are supposed also to look at the shape formed.
Which shape?
I thought that we must also look at the shape formed. Maybe it is a must to maybe form a triangle.
No. It's not a must that is going to form it. For you, what you need to master is that have I moved along the I? Have I moved along the J? And have I moved along the K? That is what matters. As long as you have moved straight, that you have moved straight along the I, you have moved straight along the J, and you have moved straight along the K. That's what matters.
Okay, teacher. Thank you, teacher.
Okay. Miracle?
So teacher, my question is, when you take this route of N to A, and then N to A.
Wait. I come. N to A, Miracle. We go.
N to A.
A
A to C.
A to?
A to C.
Now, I'm going to ask Miracle. Can I ask?
Yes, teacher.
Which direction is this that you are moving?
That direction?
Hey.
I also don't know.
Because your direction, Miracle, should either be I, J, or K. So this one is not any defined direction. So you cannot move like that. Is that fine? Miracle, is that okay?
Yes, teacher.
Now, but that route, you continue now, you move along. I'm going to show you that any route you take, you get the same answer. You move. As long as you move along I, J, and K.
A, then should I say A to O? I don't know.
That is okay.
And then O to G, is it? I don't know.
No, you must move. It must either be along the I, the K, or I. So you don't move diagonally.
Okay.
From here, where do you go?
O to D. Then D to G, is it?
Yes, that movement is okay as well. The only thing now you need to know is that here, this is going to be -1. Do you know why?
Yes.
Why?
Because of the ratio. It is opposing the what? It is opposing the y.
What about here?
That will be -4.
-4. What about here?
That will be 4.
What about here?
That is also 4.
That is also 4. Now, what do you do? Now, you combine. Here, this was -J, -1J, plus -4I, plus this was K, which was 4K,
Yes.
plus this is 4J. So when you collect like terms, -1J plus 4J, you end up with 3J. minus the 4i plus the 4k.
Yes.
So you go back to the same answer.
Okay. Thank you, sir.
Okay. Yes. Don't move what? Diagonally.
Yes, teacher.
Okay. Yes, Gilbert.
Help me with the previous question. I want to just take a screenshot of the previous question.
Okay, I'm going to go back. G1.
Like, so I wanted to know, like, if it would be possible for some of us to get some other subjects that are not on the timetable.
Okay, let me like which subjects?
Like, like for me probably, because I do mega, I have math and econ, so I wanted to, if I would access for geography.
Okay, I will give you feedback. I'll give you
And also,
feedback. Hey.
like, I wanted if some of us would also join the group,
To join the what?
like the group for this help
Oh,
Zoom
okay.
lesson.
Okay, I'm going to share that link. I'm going to share the link.
Thank you.
Okay.